Hey everybody, it's me again here, Mharlyn, and for today we will be recording my submission for laboratory exercise number 6, Business Processes in Enterprise System Materials Planning. But before we proceed, I would like to personally say my apologies for using the F word and the S word and some sort of bad words that I came to use on my last videos that we have created together. I swear I really do check and cut some of the parts of the laboratories and my videos, but it just came to happen that some sort of words just slipped out, and I didn't notice that, and I failed to cut and remove some of those things and words which are not supposed to be included in my submission. And thank you so much, Mr. Tolentino, for raising that topic to me and for letting me know that I had slipped and accidentally forgot to remove some of those words in my laboratory videos. Business processes and enterprise systems, material planning. Materials management is the planning and control of the functions supporting the complete cycle flow of materials and the associated flow of information. These functions include identification, cataloging, standardization, need determination, scheduling, procurement, inspection, quality control, packaging, storage, inventory control, distribution, and disposal. It is also called materials planning. The objectives of this laboratory is to understand the concepts of materials planning, to know the different functions included in materials planning. For question number 1, enumerate and briefly elaborate the problems with MRP systems. If there are any errors in the inventory data, the bill of materials, commonly referred to as BOM data, or the master's production schedule, then the output data will also be incorrect. Data integrity is also affected by inaccurate cycle count adjustments, mistakes in receiving input and shipping output, scrap not reported, waste, damage, box count errors, supplier container. Data integrity is also affected by inaccurate cycle count adjustments, mistake in receiving input and shipping output, scrap not reported, waste, damage, box count errors, supplier container count errors, production reporting errors, and system issue. We have some examples of data integrity. For human errors, we have the data entered by mistake, the ignorance or not being aware of regulatory requirements or poor training, willfully or falsification or fraud with the intent to deceive, selection of good or passing results to the exclusion or poor or failing results, unauthorized changes to data post-acquisition. Many of these type of errors can be minimized by implementing pull systems and using barcode scanning. Most vendors in this type of system recommend at least 99% data integrity for the system to give useful results. According to Wikipedia, data integrity is also defined as the maintenance of and the assurance of the accuracy and consistency of data over its entire life cycle, and is a critical aspect to the design, implementation, and usage of any system which stores, processes, or retrieves data. The term is broad in scope and may have widely different meanings depending on a specific context, even under the same general umbrella of computing. Systems require that the user specify how long it will take a factory to make a product from its component parts, or assuming they are all available. Additionally, the system design also assumes that this lead time in manufacturing will be the same each time the item is being made without regard to quality being made, or other items being made simultaneously in the factory. Lead time is the time between the initiation and completion of a production process. A manufacturer may have factories in different cities or even countries. It is not good for an MRP system to say that we do not need to order some materials because we have plenty of thousands of items miles away. The overall ERP system needs to be able to organize inventory and needs by individual factory and intercommunicate the needs in order to enable each factory to redistribute components to serve the overall enterprise. This means that other systems in the enterprise needs to work properly, both before implementing an MRP system and in the future. For example, systems like variety reduction and engineering, which make sure that product comes out right first time without defects, must be in place. Production may be in progress for some part whose design is changed, with customers' order in the system for both the old design and the new one concurrently. The overall ERP system needs to have a system of coding parts such that the MRP will correctly calculate needs and tracking for both versions. The parts must be booked into and out of stores more regularly than the MRP calculations take place. Please note that these other systems can well be manual systems, but must interface to the MRP. For example, a walk-around stock intake just done prior to the MRP calculations can be a practical solution for a small inventory, especially if it is an open store. The other major drawback of MRP is that it fails to count for capacity in its calculations. I don't know what it is when you've done to me. La 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 la. La 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 la. Generally, MRP2 refers to a system with integrated financials. An MRP2 system can include finite or infinite capacity planning. Nevertheless, to be considered a true MRP2 system must also include financials. In the MRP2 or MRP2 concept, fluctuations in forecast data are taken into account by including simulation of the master production schedule, thus creating a long-term control. A more general feature of MRP2 is its extension to purchasing, to marketing, and to finance, integration of all the functions of the company. ERP has been the next step. Question number 2. What are the solutions to data integrity issues? Bill of material. Bill of material. The best practice is to physically verify the bill of material either at the production site or by disassembling the product. A bill of materials or product structure, sometimes bill of material, BOM or associated list, is a list of the raw materials, sub-assemblies, intermediate assemblies, subcomponents, parts, and the quantities of each needed to manufacture an end product. Cycle count. The best practice of cycle count is to determine why a cycle count that increases or decreases inventory has occurred. Find the root cause and correct the problem from occurring again. A cycle count is an inventory auditing procedure which falls under inventory management, where a small subset of inventory in a specific location is counted on a specific day. Scrap reporting. Scrap reporting can be the most difficult area to maintain with any integrity. Start with isolating the scrap by providing scrap bins at the production site, and then record the scrap from the bins on a daily basis. One benefit of reviewing the scrap on site is that the engineering group can take preventive action. The scrap reporting module provides the ability to track, record, and analyze information about the cost and causes of scrap. It can also create a journal entry to adjust the cost of scrap out of manufacturing and into specific scrap accounts. A scrap report can adjust for both finished goods scrap or component scrap. Receiving errors. Manual systems of recording what has been received are error-prone. The best practice is to implement the system of receiving by ASN from the supplier. The supplier sends an ASN or advanced shipping notification. When the components are received into the facility, the ASN is processed, and then company labels are created for each line item. The labels are affixed to each container and then scanned into the MRP system. Extra labels reveal a shortage from the shipment, and too few labels reveal an overshipment. Some companies pay for ASN by reducing the time in processing accounts payable. Shipping errors. The container labels are printed from the shipper. The labels are affixed to the containers in a staging area or when they are loaded on the transport. Shipping errors are a tremendous pain in the back end. They cost a fortune, hurt your reputation, pick up customers, and generally cause many headaches. Not only does this cost you in gross margin on the sale, it messes up your inventory too. Now, you have fewer of the expensive items in stock than the computer thinks. Production reporting. The best practice is to use barcode scanning to enter production into inventory. A product that is rejected should be moved to an MRB or material review board. Containers that require sorting needs to be received in reverse. A production cost report details the total cost, including raw materials and operating costs of producing a product. Production cost reports, or PCRs, are also sometimes called cost of production reports, product cost reports, or process cost summaries. Production cost reports vary somewhat in level of detail provided, but in general, PCRs offer a comprehensive breakdown of all expenses associated with producing a product, and they typically conclude with a section that computes the equivalent cost per unit. Replenishment. The best replenishment practice is replacement using barcode scanning or via pull system. Depending upon the complexity of the product, planners can actually order materials using scanning with a min-max system. Replenishment is the movement of inventory from upstream or reserved product storage locations to downstream or primary storage, picking, and shipping locations. The purpose of replenishment is to keep inventory flowing through the supply chain by maintaining efficient order and line item fill rates. Hey everybody! Once again, thank you so much for being with me in this activity. I am very much thankful for the time and effort you have given in getting through and checking my laboratories. Please be with me on my next set of laboratories in the next chapter of this course.